Welcome to the class, dear students. In today's lecture, I am going to explain you the very important theorems in vector integration. So far, we have done the vector differentiation. In that, we have done different problems on gradient, how to find out the gradient, how to calculate the curl, how to find the divergence. These are all on vector differentiation. Now when come to the vector integration, we have to see the problem where wherever there is a positively oriented curve C is there and a piecewise smooth simple closed curve suppose, and D is the region which is enclosed by the curve. Then if P and Q have continuous first order partial derivatives on the region D suppose, then it is defined by the Greens theorem states that integral of P dx plus Q dy is equal to double integral of dou Q by dou x minus dou P by dou y dA. So here we are defining the given functions P and Q, and both the functions P and Q are having the first order partial derivatives. Then only it is applicable, this Greens theorem is applicable to find out the double integral of these functions, the difference between these two partial derivatives and with respect to the area dA. So now let us see the problem how to solve this. Use Greens theorem to evaluate integral of y power 4 minus 2y dx minus 6x minus 4xy cube dy, where C is a rectangle with the vertices 0, 0, 6, 0, 6, 4, 0, 4. So this is what the problem given to us. So how to solve this problem? By using the Greens theorem. The first and foremost thing we have to identify is what is P and what is Q. Always compare the given integral 1. Compare the integral 1 with integral P dx plus Q dy. Then what we get, that is the first step we have to do. So P is what? Y power 4 minus 2y, and Q is C minus of, keep minus also, so that is minus 6x plus 4xy cube. This is what your Q. Then what is according to the Greens theorem, what it says? So this integral says that it is double integral dou Q by dou x minus dou P by dou y. Now since it is in the xy plane, dA can be replaced by dx dy. So this is what the Greens theorem statement. So our job is to find out what is dou P by dou y. What is it? It is 4y cube minus 2. And what is dou Q by dou x? It is minus 6 plus 4y cube. So let us now calculate what is dou Q by dou x minus dou P by dou y. So that is minus 6 plus 4y cube minus 4y cube minus 2. Correct? So now that gives you minus 6 plus 4y cube minus 4y cube minus of minus plus 2. So this 4y cube gets cancelled. So you will remain with minus 4. So the value is minus 4. Now we are going to find out the integral, this one. Now this is double integral dx dy. So our job is to find out the limits now. What are the limits of x and y? For that he has given you the hint that it is given the curve is that is a rectangle with the vertices, this one. So let us now do the continuation of the problem. He has given you that it is a rectangle, correct? So let us draw the rectangle. And what he has given you is the vertices 0, 0, 6, 0, 6, 4, 0, 4. These are the vertices of a rectangle. From this, we can find out the limits. What are the limits of x now? X is from 0 to 6. X limits are from 0 to 6, okay? And y limits are from 0 to 4. 0 to 4. Y coordinates are 0 to 4. So, y limits are from 0 to 4. X limits are from 0 to 6. So, the next one is you have to find out the double integral. What is the answer for this? Dou q by dou x minus dou p by dou y dx dy, and x limits are from 0 to 6, y limits are from 0 to 4. So, please be careful while putting the limits. So, now when you put x is equal to 0 to 6, what it is now? Let us see, y is equal to 0 to 4. Now, integral 0 to 6, x is equal to 0 to 6. What are the value? What is the whole function value? We got it as minus 4. So, replace minus 4 dx dy. That's it. So, now what it gives you? Integral y is equal to 0 to 4 minus 4 times of integral dx. Integral dx is what? X within the limits 0 to 6 dy. Over. Now you take again. Now it is just the recap of double integration. So integral minus 4 comes out. Y is equal to 0 to 4, and upper limit minus lower limit gives you 6 dy. So it is minus 4 into 6, which is minus 24, into integral dy is y within the limits 0 to 4. So the value is minus 24 times of 4 minus 0, that is 4, and that gives you the value minus 96. I hope it's clear. So this is what the value of the integral. Next. I hope you could understand the problem. What we have done is, step 1 is finding out the value of this one, and then what is p and what is q we'll find out. What is dou p by dou y and dou q by dou x, and then solving this and then putting in the integral, then we get the result. That's it. So this is what the value, but now you have to take this as minus 96. So area, so always put 96 as the answer. Modular value it is. So take it as 96. I hope you could understand. I'll do now one more problem on this Greens theorem. So try to understand now. Let us go to the next problem. What's the problem here is, use Greens theorem. Use, second problem number 2 is, use Greens theorem to evaluate integral xy dy minus y square dx, where c is the square with the vertices, is the square with the vertices 0 0, with the vertices 0 0 0 1 1 0 1 1 0 0 1 0 0 1 1 1. These are the vertices. So evaluate this using Greens theorem. Evaluate using Greens theorem. So this is what the problem. So how to solve this now? First what we have to do? We have to compare. So when you compare, what is the Greens theorem statement? First of all, integral p dx plus q dy is equal to double integral dou q by dou x minus dou p by dou y dx dy. Always write down the statement first of the given theorem. Now when you compare the given equation, let us call this equation as 1. So from first equation, what we get? The value of p. The value of p is minus y square. Did you understand? Did you verify? Because here it is minus y square, because dx component is what? P. dy component is q. I hope you could understand. So don't get fast and solve it like taking p as xy and q as minus y square. From the beginning the answer will be wrong. So you have to take properly. And what is p is y square minus y square and q is equal to xy. Now our job is to find out what is dou p by dou y. What is dou p by dou y? It is minus 2y. And what is dou q by dou x? It is y. So this also we know. Now what is dou q by dou x minus dou p by dou y? This is what we have to find out, right? So it is y minus of minus 2y, that is y plus 2y, which is 3y. That's over. Now what he has given you? He has given you that there is a square whose vertices are given as 0, 0, 1, 0, 1, 1 and 0, 1. So these are the vertices of the square. So now you can find out the limits. Therefore, the limits are x limits are from 0 to 1 and y limits are also from 0 to 1. So now we are going to integrate according to the given problem. Therefore, what is the solution? The solution is double integral dou q by dou x minus dou p by dou y dx dy. X is from 0 to 1, y is also from 0 to 1. Correct? So now what are the limits here? Double integral 0 to 1, 0 to 1, put the bracket here, and dou q by dou x minus dou p by dou y, we got it as 3y. So it is 3y dx, close the bracket, dy. So now integral 0 to 1, 3y comes out, integral dx is x, within the limit 0 to 1, dy. So it is 3y x within the limits of 0 to 1 means it is 1. 3y dy means it is y square by 2. Within the limits 0 to 1. So the value is 3 by 2. So the value of the integral is 3 by 2. That is 1.5. I hope you could understand now how to use Greens theorem, how to evaluate Greens theorem. You have to understand what is P and what is Q, and find out dou p by dou y and dou q by dou x, and then substitute in the Greens theorem statement and then use the integration methods. That's it. Thank you. This is what the Greens theorem